See, our entire body is made of chemical substances. Everything, right from here to the needs of our toe, everything is being made of chemical substances. Okay. Out of this, some of the substances are only found in the living systems. It may be plants or animals. Okay. And these are found to be essential for our existence, for our growth, and deficiency of any one of them is going to create some problem in our life. So those molecules are generally classified into biomolecules. We will only discuss the broader perspective. We will not go in fine. So generally the substances which are essential for our life, our living system, are carbohydrates. This is the source of our energy. Then you'll find proteins. Then you'll find lipids. Lipids, we get it in the form of fats. Okay. Then we have nucleic acids. These are these nucleic acids which transfer our hereditary to the offspring and also responsible for the manufacture of protein in our body. Then we have enzymes. Enzymes are made of proteins only, but their function is different from the normal protein. Enzymes which are abundantly used in all the biochemical reaction which takes place in our body in the form of catalyst. We have hormones. Okay, hormones also are made of protein, but their function is different. And vitamins. So these are all biomolecules. These are the things that we are going to study. In our present syllabus, this is not there. Hormones. Anyway, I will tell you briefly. So these are these compounds that we are going to study. Okay. So initially we will go for carbohydrates. Carbohydrates you already studied in the lower classes. See, initially the name was derived from such a definition, later on, which in this definition we found is little faulty and we have discarded. So I'll write the original definition. If hydrate means water. It is wherever you get a compound where you find the carbon atoms are associated with water molecules or hydrogen and oxygen in the ratio of water molecules. So those are called carbohydrates. Okay. So what will we write here? These are the compounds of carbon, hydrogen, and oxygen, where hydrogen and oxygen atoms are present in the ratio of water. What can be general formula? General formula is CxH2O(Y). Okay, so this was the definition of carbohydrates for a long time. But when X is equal to 2, and Y is equal to 2. Then the compound that we have got is C2H22 or C2H4O2. We find the only one compound is possible with from this formula, but this compound did not behave like the other carbohydrates that we have. Okay, this is nothing but acetic acid. All right. So in this case, you can get the compounds in this way, where it is found that suppose it is C4H24. Okay. So in that case, you can also get formula like this: CH3, CH2, CH2. Let me see. I am not correct. May not be correct. See here. Let us see how many are there. 8. No. So it is 3 plus 2, 5 plus 2, 7 plus 1. But this is we find. This is also. No. So this is with this one we cannot write. All right. So because of that, this definition was not found to be correct. So we have abandoned. So we are not going to write this definition. Don't write. So, nah. So in this case, we have changed the definition of the carbohydrates and it is found to be most appropriate. So what we'll write now? These are optically active polyhydroxy. That is, they have lot of hydroxy group. Polyhydroxy aldehydes and ketones. Therefore, this is the definition for simple carbohydrate. Or the compounds on hydrolysis give optically active polyhydroxy aldehydes and ketones. So this is the modern definition of or present definition of carbohydrates. Write down. Hello.
Yes, sir.
Okay. Now we'll go for classification of carbohydrates. Okay. There are various ways the classification is done. One of the classification, the first classification which has been given by the people, somehow it is not being included in your book. Okay. Okay. Now we'll write here classification. Okay. First one is called sugar and non-sugar carbohydrates. Right. So now we'll write here what are sugars? Sugar carbohydrates. The carbohydrates which are crystalline, water soluble, and sweet in taste are called sugar. See, this one you already know it. What are the examples? We can call it cane sugar. Actually, that name also you know. We call it sucrose. Okay, now why do you call it cane sugar? Hello, any idea?
Derived from sugarcane. Sugarcane.
Then what is the other source of sugar?
Fruits.
See, for a commercial purpose, sugar or sucrose can be obtained in bulk from two sources. One is from sugarcane, but in all the countries, sugarcane does not grow because sugarcane grows in the tropical areas, but plenty of rain is there. So the other major source of sugar which is being commercially exploited is sugar beet. Okay, even in cold places also, wherever the rain is also less, sugar beet can also be cultivated. So because we are using from sugarcane, we call it cane sugar. Sucrose, then glucose. These are all crystalline and water soluble. These two you have already taken it and seen it. This one though you have not seen, fructose. Okay. This one I don't know whether you have seen it or not. Lactose. Lactose is present in milk. We get it from milk. But lactose, you have used it, but you do not know that you have seen it or nobody has told you. See, lactose is the ingredient in which you find homeopathic medicines are being made. All the white pill and the white powder on which the homeopathic medicines are being absorbed are lactose. It's called milk sugar. Okay. Then non-sugar. Non-sugar is just opposite. Non-sugar carbohydrate. So I'll write everything opposite. The carbohydrates which are amorphous, water insoluble, and flat. This is tasteless. Flat in taste are called non-sugar carbohydrates. This example also you know, and two of them are major source of our food. Okay, one is starch. See, starch does not have any crystalline structure. Starch you can get it from wheat, starch you can get it from rice, and there are plenty of vegetables who are filled with starch. One of them grows abundant in Meghalaya, especially in and around Shillong, is the squash, piscot. Okay, all the flesh of the piscot is nothing but starch. Potato, all right, all underground, which grows underground, whether it's a turnip, walnut, col, radish, everything contains starch. Starch. Then the leafy substances that you take, we call it cellulose. All right. Now the starch which are kept reserved in our body for our emergency purposes is called glycogen, etc. Right now.
Thanks, sir.
Okay. Then we go for the second type of classification. We call it reducing and non-reducing carbohydrates. Reducing and non-reducing carbohydrates. All right. So, reducing carbohydrates. Reducing carbohydrates. All right. Those carbohydrates can reduce tolerance reagent or failing solution. Failing solution are called reducing carbohydrates. Why do they reduce? These have free aldehydic or ketonic group in aqueous or have everything I will discuss later on. Hemiacetal structure. This one I will explain you later on when we discuss the structure of the carbohydrates. For example, all saccharides. Will write glucose, fructose, galactose, etc. are reducing sugars, including maltose, lactose, etc. See, I'm not that good in carbohydrates because for some of the reason I did not teach in college carbohydrates for last 35 years. I started reading carbohydrates only when I started teaching class 11 and 12. So I'm learning. Then we will go for non-reducing sugar. Just you do opposite. Non-reducing carbohydrates. Okay. Those carbohydrates which do not reduce tolerance reagent or failing solution are called non-reducing carbohydrates. Example, please remember sucrose. Okay, I'll write here one more thing. These carbohydrates do not produce free aldehydic or ketonic group in aqueous solution or do not or have acetal structure. No, will not write that. Do not have hemi acetal structure. Example, sucrose. Then starch. Then cellulose. Then glycogen. etc. Is it? Saccharide word is being taken from sweet. Even in Sanskrit also, the sweets or sweet substances are called sharkara. From there only, Urdu or Hindi word is called shakkar. What we call chini or shini in Khasi. Okay, it's come from saccharides. Okay, now saccharides again can be classified into three categories: monosaccharides. Okay, these carbohydrates cannot be hydrolyzed. Cannot be hydrolyzed further. That is, if you add water, they will not break down. These carbohydrates cannot be hydrolyzed further. Okay, so they are the simplest carbohydrate. That is, these are the simplest carbohydrates. Right. Okay, then we can write this comprises of 3 to 9 number of carbon atoms. Okay. They can be further. I'll not write here. I'll write. This is C, capital C. This is capital C, and this I'll write 1, Roman 1. And this they can be further classified on the basis of aldehyde or ketonic group as aldoses and ketones. Name them, So we'll write now here aldoses. So yeah, number of right here now below. formula number of carbon atoms. Formula it starts from 3. It is 3. So what will be the formula? C3H2O 3. Okay. It is called aldo trios. Then okay, and I will write ketosis and have the general formula as CnH2O n. So 4 is C4H2O4. So we call it aldo tetrose. Okay. 5 C5H2O5. We call it aldo pentose. One of these you already read also in your book. It's called ribose. This is the sugar which is present in RNA. Ribose. C6 is a very famous one. This C6H2O6. We call it aldohexose. Aldohexose. Example, very famous one is glucose. Right. Can I write the upper portion?
Yes, sir.
So
Yes.
that aldo tricores or what, sir?
Trios. Sorry, yes.
Trios.
Correct. Sorry.
Okay, sir.
You are correct. Good. Correct. We call it aldo. TRIOS.
Thank you,
Aldo.
sir.
So please again write here, just like this. You write here, ketosis. Ketosis. Okay, everything is same. Only the instead of aldo, you'll write here keto. Ketotetrose. Okay, you write here now ketopentose. Okay, we call it ketohexose. Example is fructose. Fructose. মৌসুমরা কাটা যেত না, সব মৌসুমরা আই গেছে, যতই পাশে হাঁটলেও একটা দুইটা আই। Finish. So saccharides, first one we have done is monosaccharides. Second is oligosaccharides. The carbohydrate with on hydrolysis can be 2 to 10 monosaccharide units are called oligosaccharides. The term oligo, okay, has been come from the, don't have to write it, Greek word, okay. See, the first democracy in the world is started in Greece. People elected 10 persons from the country and they used to run the administration or government. So those type of government were used to call oligarchy. From there the word oligo has come. Okay, now we have found it can give us 2 to 10 monosaccharide units. So if it gives 2, then we call them as disaccharides. So we'll write down here. they can be further classified on the basis of number of monosaccharide units. Number of monosaccharide units produced in the process of hydrolysis. Okay. So now we write here now. Disaccharides. These are constituted these produced two units of same or different monosaccharides on hydrolysis. Okay, so example. Okay, so now we'll write name. Formula. Then you write here now monosaccharide units. Glucose. You'll find all of the formula is same. Glucose. See, sorry. Sucrose. Cane sugar. Okay, formula is C12H22O11. What it will give you? It will give you C6H12 O6 C6H12 O6. I'll write now here H2O. I'll write here H plus. So you get here glucose and you get here fructose. Okay, then we will get here now maltose. Formula is same, C12H22O11. So on hydrolysis, it will give you 2 units of glucose. glucose. See here, what did you say? This produce, so this produce 2 units of same, see it is same, or different, they are different. Okay, we'll just change it. Please do the correction. Same or different monosaccharide units. All words do not come immediately. So, then we write here lactose. Lactose we chemists we say, but we generally people say as milk sugar. Okay. C12H22O11. It will give you C6H12O6. This is called galactose. And 1 unit of glucose. Okay, now this example is raffinose. Its formula is, see, in glucose you have 6 carbon, na? So 6 into 3 is 18. And 12 hydrogen. So 12 into 3 is 36. Minus 2 will be 34. S is 34. And 8. Is this. So here you will get 3 units. H12O6. This is glucose. Then C6H12O6. This is fructose. Then C6H12O6. This is lactose, etc. If it contains 4, then we call it tetrasaccharides. Anyway, yes.
H34, H36.
See here, I will tell you how to count it. Very good boy. See from here you know. See, it is C12H22O11. When I add water, what happens? So I write it now here, H2O. It becomes C12H24. Then I divide it by T. 2, what do you get here? C6H12O6. Do I not get this? Huh?
Yes, sir.
Yes. So in that case, I have added 2. So it will be 2 molecules will be, yes, it is 32. Here 3 na, so I have to add 2 molecules water. You'll know after some time. Chemistry is not difficult. Just use your common sense. Okay, tetrasaccharide example is tracheose. And you forget. Eugenia is not there. What? Hello, Eugenia. Huh? Hello.
Not here, sir.
Eugenia is there or not there? Polysaccharides. These are high molecular mass carbohydrates which on hydrolysis produce more than 10 monosaccharide is because they are large molecular mass molecules, so these are also called macromolecules. These are also called macromolecular carbohydrates. Okay, now and have the general formula of CnH10O5. No. So not Cn, C6. N. Okay. एग्जाम्पल क्या है? स्टार्च, सेलुलोज, ग्लाइकोजन, etc. Wait, now I have to see your book. Okay, we'll go now for monosaccharides. In the monosaccharides, we are going to discuss about glucose. This is the most abundant monosaccharides found in the nature. Okay, they exist both in the combined state and the free state. So where do you get maximum monosaccharides, glucose? Glucose are generally found in the fruits. Okay, any ripened fruits contain huge amount of glucose. All right. So this is the most abundant monosaccharides in the nature. All right. Now how to see? Generally, we do not prepare glucose when it is found in nature. Should we be so foolish to prepare it in the laboratory? Okay. The cost if you prepare glucose in the laboratory, cost will be not less than 20 times of the glucose that you get in the market. All right. Then where from we can get it? So when we are going to write preparation. Now, it can be obtained. Glucose can be obtained from the hydrolysis of cane sugar. It is sucrose. All right. So when cane sugar solution is heated with dilute hydrochloric acid or sulfuric acid, give a mixture of equimolar mixture of glucose and fructose. Okay, so we'll write now here C12H22O11. Here we are going to write here sucrose and bracket I'll write here now cane sugar. Okay. Right here now. Dilute HCl or H2SO4 heat. So you write here now C6H12O6 glucose C6H12O6.
Done, sir.
Okay. But you know it is not a good method to prepare. Why? Because it's very difficult to separate glucose from fructose. So this is only of our knowledge. But in our industry or in laboratory, we do not adopt this method of preparation of glucose because the isolation is different. Both are equally soluble in water. and it's very, very difficult to separate. So these are only of sub academic interest. So first method, what did you write there now? So please write one thing. On the top of this, you write from starch. Sorry, from cane sugar. Then please on the top you write from cane sugar or sucrose. Okay, this is the heading of the first. Then the second, you write now here from starch. You will write now here commercially glucose is obtained by the hydrolysis of starch in presence of dilute H2SO4 or HCl by heating under pressure. Because it's a large molecule, so in that case you have to heat it at high temperature and subject to pressure. Otherwise the process will be very, very slow. So what do you write? C6H10O5. All right, N plus N molecules of water. Okay. I will not write here N molecules of water. Why? It will be N minus 1 number of molecules of water. See, we have found when I take sucrose, no, it will be N molecules. N H2O. And here we will write here H plus. Here we will write heat and pressure. We get now here NC6H12O6. Why? Because starch is only made from glucose. So we getting here. So we do not have any impurity present in it. Even if the impurities are there, no problem. You can cool the solution. This is highly soluble in water, and we know starch are not soluble in water. So you filter it, okay, and you get perfectly pure glucose. So all the commercially available glucose we prepare from starch. So if you buy a packet of glucose, you just see is written there from where it is being obtained. Generally, we do not obtain from rice or wheat. The reason is that this is our staple food. So the food which the substances which are rich in starch and which is not being consumed in huge amount, from there only we prepare it. Example, corn, okay, makai, we prepare it. All right. So today I'm going to end here, because if I start the chemical properties, I will not be able to finish it, and lot of discussions are there. So I'll start, do it on Saturday. Thank you.